What is the standard
Um,
form of a line?
what?
What's the standard form of a line?
Um, I don't know.
So do you remember
There's
when we
so
were doing linear equations early? I'm not a huge fan of how the book ran through linear equations because they kind of called them linear equations, but we never really talked about why. Do you remember how we used to talk about linear equations? Actually, Bryn, you got audio on your end? It's like I just joined and now I'm getting called on.
Yeah.
There you go. Do you remember? So Brennan, you and I were actually talking about linear equations back in like the beginning of the semester, and we were like, "How do you know they're linear equations?" And you were like, "You just graph them, right?"
Yeah.
And that was a great answer. I loved that one. Do you remember the way that the book wanted us to recognize linear equations a while ago?
No.
Okay. The way that the book first introduced linear equations is it was talking about literally if you have a number times variable like x, and you could do this as many times as you want, so you could have numbers and other variables like y, and that would be numbers. So literally what you have is numbers and variables being multiplied and added. You only have one variable, no exponents, no nothing. All of this stuff going on over here. Do you remember that, Bryn?
Yes. Yeah.
Okay, good. So then that's how the way that they actually categorized them is they said, well, since you could have different numbers in front of the x and different numbers in front of the y, they had them written where I think it was ax times by equals c. So a was a number, some number, I'm just not telling you what it is. B is a number, c is a number. And so this was what they were calling their standard form. This was the first way we learned how to recognize linear equations. In my mind, it has uses that are not exactly the way we started with teaching it, but that's what the book wanted to do, so I had to kind of go along with it. So thanks. I remember that sparked a conversation you and I had because you were like, I just graph them, and I was like, oh, we're not even there yet, but you know so much. So I was like, okay, great, we'll come back to that in a little bit. Thanks for that one, Brent. Now, Bree, this is the standard form. This is what they say is like the best visual way to recognize if something is linear. Like besides graphing it, is just do you have variables that are you have an x and a y, and is the only thing that's happening with the x and the y that they're being multiplied by a number.
Okay.
Okay. Now keep in mind this has a slight caveat, which is not only could they be multiplied by a number, but they could also be divided by a number. Because dividing by 4, I could change my perspective and think of that as multiplying by 1/4. True?
Yes.
Okay. So the multiply is a little loosey goosey there. I guess it's really just number that could be written as multiplying would be a more technical definition.
So I'm confused because the equation they give in the problem is already in that form, but then it gives me points that it's passing through as well.
Okay, what does the full question ask?
So it says passing through 3 comma negative 2 and parallel to a line whose equation is 5x minus 3y equals 6.
Like this one here?
Yes. No,
Okay,
not negative 6, just positive 6.
positive 6. Okay, good. Bryn, what can I do for you?
Oh, I was gonna say something, but then
About the question?
I was just about that.
What are you thinking?
Can't you just plug in the X and Y? Can't you just plug in the X and the Y?
Plug in these ones here.
Mm-hmm.
Okay, let's try that out. Let's try this all out together. It's actually a wonderful suggestion. Let's do that. 5 times x, I guess, would be 3, minus 3 times negative 2 equals 6. Let's simplify this down. That means 15 plus 6 equals 6. What you thinking, Bryn?
Mm,
A little surprising, huh? Say, what do you think?
Um, so wouldn't we have to find the slope? Like, the question what's the question isn't the question write an equation for line in point slope form?
Right now it says write one in standard form. We could write it in point slope form. I'd be happy to extend this problem. We'll talk about how we could do that one for your practice as well, if you'd like. But right now the question is that we are being asked for this, something of this structure, and we're being asked for it to go through this point and be, I think it was parallel to this line right here. Now, we're just exploring right now. Right now, I love the idea that we're just playing around with doing things. So I'm not expecting correct answers from anybody. I'm expecting trying things and then interpreting if it worked or if it didn't work, why that is. So let me see, Bryn, did you have a thought on this one?
Oh no, I was just gonna say that you would need two pairs to do the slope, and we only have one
Ah, okay. So why do we need 2 points?
because the slope intercept form is y2 minus y1 over x, but we only have an x1 and a y1.
Okay, so a couple things to clarify on the point slope form. This is, again, some good things. We're throwing all that out on the paper. And this is how true math happens. True math is just about throwing everything we know until we find the things we want, and then we make it look elegant. And everybody looks really impressed at us about how we did it in so little time. And it's like, no, we just only showed you the little bits that actually were great. It's like writing a paper or writing a book. Like a 400-page book takes like 4,000 pages to write. You just don't show everybody the other, 3,600. Okay, so we've got all of this. Keep in mind that in the point slope form, we've got a couple of different y meanings. This y here means a generic any y for the line. This means a specific starting point, a first point for the line. So we're going to keep this as a variable. This is just a number that I'm going to be using. This is a number I'm going to be using for x. This is the variable for any x value that's on the line, and then we have the slope. So I think what I was seeing from Brent, if I'm interpreting you correctly, you're saying that in order to get a line, we need to have 2 points, and we could do that from maybe one of them being the y1, x1, and then does the other one help with the slope?
Yeah, can I say something else?
Sure.
Can't we just manipulate the 5x minus 3y equals 6 and make it, put it into slope intercept form?
Okay, can you tell me why you would want to do that?
Um, I don't know. It's just a
Okay.
thought.
It's a thought. I have no problem with thoughts. I love thoughts. Let's see if we can do the motivation before I go through all the calculation. I'm doing all the calculation work up here. Y'all are like, yeah,
We're
can't we
supposed to be
calculate
putting it
anything?
into standard form, and is if we're putting it into standard form, wouldn't the standard form be the slope intercept form?
Nope, standard form is this one right here. It's
And
saying I
then
want to organize it so there's numbers
okay.
times x plus number times y equals number. As well as somebody could maybe tell me why it was that when I plugged the point into this line over here, I got something that made no sense. So we got 2 questions. Maybe the first would be, what did I just do and why did it not work? The other thing would be, what could I do instead? So I'm going to first look around for anybody who has an idea of why it was that when I plugged in this point into this line equation, I got something crazy. Will, go ahead.
Aren't you supposed to plug, like, don't you, I believe, I don't know if I'm correct or not, are you supposed to plug in, like, x, like, okay, so say for example, 3 is x, so aren't you supposed to plug in 3 for x and then solve for y, and then, like, do the opposite of that?
Well, I got 3 and I plugged it in for x. I absolutely did that. I took this and plugged in for y because that's the y that should go along with the x. So I guess I really don't need to solve it. It already tells me what the y is for that x. But it seems like when I tried to do that, when I tried to plug in x and y the way that we might have thought, I got something crazy. Bree, you've heard a bunch of different ideas now. Let's go over to you. What are you thinking? What's looking weird?
I don't know what's going on over here.
Okay. Okay. I'm going to lend a little bit of clarity, and we're going to try to calibrate us all back together. So first, again, these types of problems, because there is modeling that's happening, there's creativity and there's concepts being put in here. Avoid the cat and milk mistakes. So just like the story I told some of you, I had a teacher who said that one day he came home and his 5-year-old kid had dumped milk on the cat, and when he asked the kid why, the kid said, "Well, because the cat, likes to lick itself and enjoys milk." It's like that's a perfectly reasonable thing to do then, is to pour milk on the cat, if you ignore all the context. And this is where we really start to get into those kinds of problems if we're not careful. If we just see things and grab them and throw them into other places, yes, we've got the idea in that they look familiar and they're triggering ideas in our head, but we need to make sure that we understand the full story as we're going through. So, Bree, you're going to help me out with this one. What's important about this point?
That the line passes through that point.
Which line?
The new line that we're creating.
So this line over here passes through that point.
Yes.
Does this line pass through that point?
No.
Not necessarily, and in fact, when we checked, it didn't work. So we can actually confirm this point has nothing to do with this equation.
Right.
So this whole thing that we did right here, this was a cat and milk mistake. This was us grabbing x values and y values and throwing them in where we saw x and y. perfectly great that everybody saw that there were x's, saw that there were y's, but if we run that thing through too much without understanding the story, we get into a little bit of a hiccup where we get confused and we wonder why everyone's mad that we spilled milk. Now, this also is a perfectly true way of talking about a line. This is the point-slope form of a line. Are we being asked to make a point-slope form of a line, Bree?
No.
We're being asked to make a standard form. So we could use this, but I just don't have the motivation for it yet. So let's keep this in a parking lot of ideas, and we'll pull it in when we have the motivation. Fair?
Okay.
Okay, so let's go back to the early premise. Any type of line needs two pieces of information, one of two combinations of information. Give me something that I could use to make a line with no ambiguity.
Know that the other standard form one that it gave us is parallel to
Okay,
the new
so
line.
that's this problem specific. I'm going to go back to early, or like the basic parts of a line. What do I
Okay.
need to make a line before I even get into this problem?
Coordinate points.
How many?
At least 2.
Good. At least 2 coordinate points. Do I have 2 coordinate points right now?
I don't think so.
No. How many do we have?
1.
We have 1 point. Okay, that's a bummer. Cannot use the approach I would if I had 2 coordinate points. Okay, what is a different way that I could draw a line? So that was one combination of information. If we get 2 points, we could probably begin our workings. The other is I would need what?
I don't know. Like a starting point and a slope? I don't know.
There we go. A starting point and a slope. Because if I just asked you to draw a horizontal line on the paper, and I said, if you draw a horizontal line, but it's not the one I'm thinking of, you get a 0 for the course. You'd be like, that's not fair. You could think of any horizontal line, right?
Yeah.
But if I said I need you to draw a horizontal line through here, then it becomes an easy problem. True?
Mm-hmm.
Good. So that's what we're going to talk. So we're going to approach this entire thing from the slope and point standpoint. So those are the 2 things that we determined we need. We need a point. No problem. I've got that. That is 3 comma negative 2. And we're going to need a slope. We have a slope.
No.
Okay, so that becomes the goal that we're shooting for right now. We need a slope. This right here wasn't helpful. This right here is a good parking lot idea. How do we get a slope? I'm going to throw this around to the audience. Who has an idea of how we could find a slope? What other information do we have in this problem that could help us go down the slope search?
I agree with Bianca actually. I like
Why?
the A over B over idea. That I'm not too sure. To me, it just makes sense.
I'm glad that it makes sense to you, but I'm not convinced yet.
I don't know how to explain it. I need somebody else's help to like get the words like out. Like
That's perfect. All right, Maddie's throwing it to the audience. Somebody help out. Do we want to go with A divided by B? I'll remind everybody of the original question. We're trying to draw a standard form of a line that passes through the point 3 comma negative 2 and is parallel to the line 5x minus 3y equals 6. Bill?
What in this?
And then I'll come over to you, Karen. Will, go ahead.
So, question. Parallel means that the line has the same slope but a different y-intercept, correct?
It actually could have the exact same y-intercept. It's just another be parallel because it's literally the exact same thing. But yes, parallel means same slope.
Which means we're trying to find the line that is parallel to the 3 comma negative 2. That's where it passes through.
Well, I've already got the line it's parallel to. I've got this all right here is the line that it's parallel to.
Oh, okay, 5x minus
I
3y.
just don't know what the slope is and all that crazy.
And then that's when you do, okay, you're trying to find the slope, correct?
Yes.
So you subtract 5x on both sides, which gives you negative 3y equals 6. Negative 3y equals 6 minus 5x. And then from there, you would divide negative 3 on both sides because you're solving for y, the y-intercept. The slope, which is y equals mx plus b. So that means y equals, 5 over 3x minus 2. Then your slope would be 5 over 3.
Bree, what do you think of all that?
That looks pretty good to me.
Okay, talk to me about the logic of why all of this works.
Because the equation it gave us has the same slope as what we're looking for, so we found the slope off of the equation that was given.
Okay, and we found that how?
By rearranging the equation into slope-intercept form?
That's very nice. So, Will, that's exactly the only thing I would have given you feedback on, is you said that we were solving up for the y-intercept. We're not doing a y-intercept here. The correct is that we're solving for the slope-intercept form, and then from the slope-intercept form, it's just easy to pull out what part is the slope and what part might be the intercept.
Yeah, that's why I had corrected myself. I meant to say the slope-intercept form, not the y-intercept.
That's perfect. Very nicely done. Now, Karen, did you have this idea or a different idea?
Yeah, that was exactly what I was about to say.
You're going to suggest this one. Okay. Now, I
Yeah.
want to tie this in because, Maddie, you were talking about b divided by a, right? Or a divided by b?
Yeah,
Okay, do you see where that comes in? Because I'm going to tell you that you are correct. I just want to make sure that you know the details behind why and where.
yeah. I was in the middle of typing the chat thing. It's like I know how to do it, but like I can't put it into words. So like thank you
So
for whoever explained it.
B? Where's the B? Where's the A?
So B, wait, what? Wait. Can you repeat that? You kind of cut off.
So what you were saying was you said that this has something to do with A and something to do with B, right?
Yeah.
I'm not quite sure exactly where that is. I want you to show it to me. So where's the A? Where's the B here?
Okay, so look at the standard form of the equation, the 5x minus 3y is equal to 6. I look at the standard form, how you literally just take the number in front of x and the number in front of y and just put the number over x over the number over y, but that would give you negative 5/3. So that's where I kind of get tripped up about explaining it.
So here's I don't know if your MyLab does this. If it does, then I hate it. But if you would like to run the absolute risk of finding a shortcut and using it completely improperly, which I think is going to happen if I promote this. Nonetheless, I will promote it because it seems like it's a thing that could work. You could think of this as saying arrange it alphabetically, so you get your x and your y, then grab the number that is in front of A, put it on top of the number that is in front of y, or take the number that's in front of x, put it on top of the number that's in front of y, and make sure you do the opposite of it. Because hidden in all of this is the idea that I've made it negative by moving it to the other side, and then I've done division. So
Okay, yeah,
if we are promoting the equation that says that you need to do the negative of b divided by a, then one, I want to dismantle that program in a very short, slow, and painful manner. But there is some truth behind that.
yeah, that's what I was trying to do. I couldn't figure out how to like explain it though.
I like Will's explanation much better because now this tells me why. It's not too much work. It gets into a more comfortable format. I can pick and choose whatever I want from lots of different information. Okay. So far, we've been trying to start with what is it that I need to make a line, and I need either 2 points or I need a point and a slope. We had the point. The point was this 3 comma negative 2, and then we've now got a slope. The slope is, let's see, 5/3. I guess I should call that probably m instead of s. So, Bree, what do we do with all this crazy? How do we actually get to our answer?
I don't know. Are we putting it into that form that we had earlier? The y minus y1 equals m times x minus x1?
How come?
I don't know.
Okay. What is this called?
That is point slope form.
Okay. Do we have a point?
Yes.
Do we have a slope?
Yes.
Would you like to form a line with me?
Sure.
There it is. Y minus y1 would be negative 2 equals m, which is 5/3, times x minus x1, which would be 3. Ta-da, I have given you a line.
Yes.
So you use the point slope form when you have a point and you have a slope because why? It was easy.
Yeah.
It doesn't look nice yet, but I got it.
Right.
Okay, now we want it to look a certain way, true?
Yes.
How do you want it to look?
Well, we need it in the standard form. I don't know how to get from this form to that form though.
Okay, if you know that this has everything we need, and now it's just a matter of play.
Yeah.
Give yourself permission to play. What would you like to do first?
Is C in the standard form the slope?
Nope, it's just a number.
It's just a number. Oh. I don't know.
Like try to simplify.
Karen, go ahead.
Will we try and like first simplify the equation and see how we can put in standard form?
Do you think it looks too complicated right now?
Yeah.
What do you think, Bree?
I could agree.
Okay, cool. Karen, carry that suggestion. What should we do to simplify this?
So negative and negative is positive, so it'll be y plus 2 is equal to, we will distribute 5/3 x, and then it will be -5 because 5 times 3 is 15 divided by 3 is a -5.
Good. I actually also would think of that in the shortcut of if I'm multiplying by 3 and dividing by 3, I can just cancel them away and
Yeah.
keep the 5.
Oh, true. Yeah.
So whatever way you want to think about it, but your explanation was just as good as mine. Okay, so now I'm going to throw it back to Bree, because this is your question. Do you now see how we could connect this to this up here?
Well, I feel like the A would be -5 and the B would be 2, but then it's like equal to the slope, but C isn't the slope.
Okay, so tell me why you think A would be this thing and B would be this other thing.
I don't know, just because they were connected in the beginning in their parentheses with the X and the Y.
Okay, so they have something to do with X and Y?
I think so.
Okay, now tell me, in this standard form that we're going for, what is the connection between X and A?
Multiplication?
Okay, so it's the only thing that's being multiplied by X.
Yeah.
Also, if I want to make it look identical, we'd probably want to make it look the furthest to the left in this equation structure, right?
Yeah.
Okay, how can we make that happen? Let's visually make this blatantly obvious. So how do we first get number times X, whatever that is, furthest left?
Furthest left. Would you subtract the 5/3x from both sides?
What would that get us?
So now it is -5/3x plus y plus 2 equals -5.
Okay. I'm going to throw it over to Will because it looks like there's a question. Will? I can't hear Will.
Yeah.
There we are.
Okay, I say we're trying to put this back into slope-intercept form, correct?
I don't know. Is that what we're doing, Bree?
Standard form.
Oh, okay, we put it into standard form. Okay.
Okay, so now what do we do here, Bree?
Would you subtract the 2 from both sides?
We could. You can. That's always a fair thing to do in math. Why would you want to do that? Tell me the motivation.
Because I don't know, I was thinking that the y needs to multiply by something, but there's really nothing to multiply it by, so I just figured move the 2 over and then it looks most like the standard form.
Okay, good, because it's got the numbers on the right-hand side, right?
Yeah.
Okay, now there actually is something being multiplied by the y. What is it?
1.
There is. So it's currently got something being multiplied by it.
Okay.
Okay. So now tell me, does this look like number times x plus number times y equals number?
Yes.
That is your standard form.
Wow. That's amazing.
Now, you could write this differently. So let's suppose that for whatever reason, I really hated fractions. I don't. I think they're wonderful. I like them much better than decimals. Decimals take up way too much space on my calculator. I have no idea where they came from. But let's suppose I did dislike that. What is the only thing here that's making me have fractions? What's the number that's in my way from having no fractions?
Would it be 3?
The 3. So I could multiply the left-hand side and the right-hand side by 3. That would get me -5x. After I multiply by 3, the 3's would cancel away, plus 3y, because I need to multiply by 3 there as well, and then that would equal -21. This is also a standard form of that line. In fact, there are as many different standard forms of this line as you want to be creative with. The only thing that makes this a standard form is that there's a number times x plus number times y equals number. What those numbers are is actually however you want to view that perspective. Changing your perspective here, you can actually change the representation of this line without changing the meaning of the line. So there's not a correct answer here. There's just, did I satisfy the fact that it looks like this, came from this, and is parallel to this, in other words, has a slope of 5/3.
Feeling good.
It's kind of creative. You might not have thought that there was a right or many right answers, right?
Yeah.
That's exactly how you want to approach these problems. What's the thing I'm going for? And then pick out the details of it. Like ax plus by looks intimidating until you realize all it is number times x and number times y equals c, and that those x's only appear one place, the y's only appear one place, all of your constants are on the right-hand side of the equal sign. If you can pick apart the details, then when you're simplifying and shifting things around, you are just aiming for that to happen. Get your x's and y's on the left, get your constants on the right, then you're done. But you can see why it is that we might want to use point slope form sometimes. It's a pretty easy one to get us started before we start manipulating it. You can see why we might want to use slope intercept form because it's a pretty good thing to pull information out of. And then this looks pretty simple and in fact is very useful for our intercepts because if I wanted to know where the intercepts are for this line, no problem. The intercept, the y-intercept would be when x is 0, so I can literally just ignore all this and then say 3y equals negative 21 to be y equals 7, or negative 7. And then for the other intercept, I would just ignore all this and say negative 5x equals negative 21. So I guess my x-intercept must be 21 over 5. Like you can pull information about the intercepts from this structure very well. You can pull the setup from this one very well, and you can pull the slope from this one very well.
Well, I'm confused now because I just tried to put both of those answers we came up with as the answer, and neither of them worked.
Ooh, not a huge fan of that. Messed up somewhere? Let me do a quick check. Did it ask for it to be represented in whole numbers only, integers?
It says type your answer in standard form using integer coefficients.
Okay, so integer coefficients means that we can't use the fractions. This is true, but we need to make it look like this. Okay, so that's one key. So everybody right now, when we finished up Bree's work, it's correct in terms of an answer, but not in terms of the question it's asking us, because it's asking us to make sure that we are writing what we had as our solution, which was negative 5x plus 3y equals negative 21. It wants a positive leading coefficient, and so we could either divide everything by -1, or I like to think of switching the sign as just multiplying by -1, because that's like multiplying by the quantity of 1 and just flipping the sign. And yes, that's going to get you 5x minus 3y equals, it was a negative 21, so I guess now it's a positive 21. Again, like I said, many, many, many different ways to answer this question, right?
Yes.
Try that out.
All right. 3y. Yay!
Hello, boot. All right,
Alright,
small little detail.
thank
It's
you.
always those little tiny details. So I'm glad to know that our thoughts were correct, our expression was correct. We were just being asked to be have it displayed in a certain way.
Okay.